Hard drives are old technology these days. Any cheap SSD will greatly outperform any old hard drive you're likely to come across. Sure, large capacity ones still have their place for bulk storage, but these low capacity pieces of spinning rust, not so much. But what if we use 2 drives, or 4 drives, or 8 drives? Windows has a feature to stripe drives together to combine their capacity, and more importantly, their speed. So why don't we try to do that and see just how many hard drives it would take to beat a $20 SSD. Right now the setup is I've got this cheap SSD to put up against this old hard drive, and then we'll compare it to this pair of hard drives striped together in Windows. To find out how much performance we need to make up with the additional drives, I'm going to run a software called Crystal Disk Mark. This will let us benchmark the performance of the hard drive and the SSD so we can compare them. I've got 2 copies of Crystal Disk Mark running. I'm going to start them at the same time on the hard drive and on the SSD. And there they go, they're benchmarking. And already, first result off the SSD, hard drive doesn't have anything yet. Right there you can tell how much faster a cheap SSD is. Right away, Sequential reads 550 on the SSD and only 83 on the hard drive. That is quite a difference. However, it's not more than 8 times faster, and I have 8 hard drives that we can plug into this at the same time. So theoretically, maybe we can make that up. The thing that we're not going to be able to make up is these random reads and writes. I mean, 28 megabytes per second on the SSD versus 0.48 megabytes per second on the hard drive. You might be thinking, what's the difference between sequential speeds and random speeds? Well, sequential speeds is kind of like moving one big thing to another place. It's going to be hard and take some time, but it's straightforward. You just get it, take it there, and it's done. Random performance would be like if you had to find 300 small items on different shelves in a warehouse. It's gonna take longer, not because it's hard to move all these tiny little things. It's harder because they're all over the place and you gotta go find them. So sequential performance is like copying a big file to another location. Random performance is like what an operating system is doing when it's loading up all the little files that make it work, and less so, but also when you're running a game. Let's see what adding 2 hard drives can do. With the drives striped together in Windows, I can open up a 3rd copy of Crystal Disk Mark, and we'll run this on the D drive. Go. Right away, 220 megabytes per second. That is more than double the single hard drive. Maybe these drives would have just been better by themselves. I don't really know, but this is looking good. I'm just waiting for that random speed to pop up. I want a score of close to 1, hopefully. Okay, 0.94. It's kind of scaling linearly. That's not bad. I mean, it's not good, but it was expected. These numbers and benchmarks in general are one thing, but I want to see how these setups actually compare running Windows or like loading up games or something. So let's do some testing with that. For this test, I've got the exact same copy of a virtual machine on the SSD, the hard drive, and the dual hard drives. I'm gonna load them all up one at a time and run a stopwatch and see how long they take. First, I'll start with the cheap SSD. I can see in Task Manager that drive is definitely doing stuff, and it's almost done already. We're at 33 seconds in, and that is 52 seconds from pressing start to the VM being on the desktop. That one's with the cheap SSD. Let's try the hard drive. In Task Manager, I can see it's now the Hitachi hard drive that's being used, and yeah, this one's taking a bit longer. We're already past 55 seconds. I wonder if we'll double the time. We're not far off of doubling the time. It's officially taken twice as long, but it's almost there. 2 minutes and 4 seconds. That was painfully slow. What's my prediction for the dual hard drives? I'm gonna guess a minute and a half. Wow, I know I technically counted this as loaded, but the interface is struggling. Okay, final test here. Dual hard drives, start. Why do I feel like this is going slower? Is it going slower? Okay, we're officially slower than the SSD here, but it is almost done. Almost. Oh, I was pretty close. 1 minute and 39 seconds. That was a pretty good estimate. So 2 hard drives was still slower than the SSD, but faster than 1 hard drive. So we've learned nothing. This was exactly as predicted. Let's try some games. This is BeamNG Drive loading off of the cheap SSD. I'm gonna click launch and start the timer. We're just gonna go for when it hits the menu here. And that would be 29 seconds. Not bad. Okay, now we're loading Beam off of the 2 hard drives. Start. Okay, well, that was almost identical. It loaded in 29 seconds. I wasn't expecting that, to be honest. I'm gonna try it on the single hard drive now. Like, is that any slower? There's no way that this isn't slower. Okay, that actually was slower. 36 seconds. Not that much slower though. Like, that didn't take twice as long, not nearly. Maybe BeamNG just really loves hard drives or something. Let's put more on there and see if we can get it to be faster than an SSD. Now we have reached the problem with adding more drives. There's no more SATA ports left. But luckily, I've got an HBA that'll let me plug in 8 additional hard drives all at once to this computer. Let's get that plugged in. We've officially entered the territory of this setup being super jank, but all of these drives are now plugged into both power and data, all running off this 350 watt power supply with these tiny little cables. I'm sure that's fine. Oh, also the graphics card is outside the case now, but it's still connected. Let's power it up. Okay, well, it's still working, although I've never seen it make this screen. No idea what this is for. Oh, there's all the drives. That means it's working, I guess. Okay. And there's Windows, so I guess it still boots up as well. This is going great, better than expected. Now we've got the real fun configurations to do. I have never seen this many drives in Task Manager all at once. This is pretty cool. We'll load up disk management and see if we can stripe some data on these things. Oh, I have to manually delete every partition on all of the drives. Okay. Oh, it does too, and then it lags out as well. This is going great. Not responding. Why? Just Microsoft stuff. Okay, now we create a new stripes volume, and I am going to add all of these drives. Disk 0 all the way to disk 7. There's not enough space available on the disks to complete this operation. Don't know how that's possible. Okay, we officially have 1 drive mounted in Windows with 7 terabytes of storage spread across all of these old hard drives. Let's do some tests. Right away, with all of these plugged in, I gotta see what these crystal disk mark numbers come out to. Alright, K drive is the cheap SSD and the E drive is the entire stack of hard drives. Let's start these both. Oh, we're destroying it right away. Read speeds on the SSD back in the like 550 range. The hard drive stack 1,187 megabytes per second. This is beating my expectations. This is working great. Okay, the random reads are coming in now. Oh, yeah, we're not close. Not even slightly close. The SSD 34. The entire stack of hard drives still could not crack 1 megabyte per second. Oh, hard drives. You tried. I'm just getting BeamNG copied over so we can test it out, and I have never seen this before. 520 megabytes per second copying to mechanical hard drives. That's pretty cool to see. While that's going on, let's get Windows 10 cloned onto the HDD pile. Just copying stuff back and forth now. The SSD on this computer, maxed out. We're reading at 200 megabytes per second. Look at all the hard drives. These things are barely working. Okay, BeamNG Drive is fully copied over and the Windows 10 VM is fully cloned, so let's start up that VM and see what time it gets. So we're aiming for less than a minute. That was around what the SSD got. Somehow I don't think we're gonna get there, but I'm hoping it's close. Let's start this thing up. Really, this is just a matter of if the faster sequential speed we've achieved can make up for that absolutely terrible random performance. The hard drives are just not great at that stuff. Let's see how much Windows needs it. Okay, we're officially slower than the SSD. Oh, 1 minute, 14 seconds. That's a shame, isn't it? It was only 15 seconds faster than 2 hard drives, and we added 6 more. That did not scale that well, I'm gonna be honest. That being said, this is still like twice as fast as the 1 hard drive by itself, and this VM is like relatively snappy for running on, you know, not a great computer. Like, yeah, you could use this computer, it works fine. Okay, gaming test. That's what I want to see. BeamNG drive, will it be any faster on the hard drive pile than with 2 drives? Goodbye, VirtualBox. BeamNG drive. Let's load this up. 31 seconds. That's not any faster, is it? That's pretty much exactly what the SSD got and exactly what the 2 hard drives got. Okay, this was a waste of time. That being said, if you're trying to get your entire Steam library installed, a solution like this could be almost as fast and way cheaper than SSDs. Think about it, a 2 terabyte SSD? That's over $100. You can get all of these hard drives used for that price, and you don't get 2 terabytes, you get 8 terabytes with this solution. Sure, it's slightly slower in random performance, but the game seemed to not care. It was keeping up with the SSD. Almost, like pretty much. I don't know, maybe I'm just trying to make excuses for this not being completely stupid. I mean, if you want to run 8 drives, you're probably going to need an HBA, and at that point you're spending more money, so you should probably just get an SSD. Yeah, probably do that. Bye.